Okay, it's been a while since we've done a video where I come out in front. You've been watching my hands for quite a while, so now we are going to do a regular video. First, before we get started, I just want to let you know there is not a printout for this. I'm going to put some printed notes later, but not for this particular subject. So you need to take old-fashioned notes. Just get your notebook, write whatever notes you need in your notebook. But this is very important information. We're going to talk about the quadratic equation. This is the new unit that we're starting into now. So let's go ahead and talk about that. The quadratic equation, our standard quadratic equation is, you can write it two different ways. Y equals ax squared plus bx plus c. Okay, that's how we graph that quadratic equation. We're going to use that particular format. If I wanted to solve my quadratic equation, I'd also do it in this format. Ax squared plus bx plus c equals 0. Okay? Now, there's a lot of things you need to understand about the quadratic equation. Some of the things we've already talked about. If you remember, when we did our function aerobics, we said the quadratic equation made a U-shaped graph or a parabola. So I'm going to write that down. Okay? They are not linear. So they don't have a slope. Instead, they create parabolas. Okay? An example of a parabola looks like this. Okay? It's a U-shaped graph. It can also look like this. That's another parabola. That's a negative parabola. And we'll talk more about that later. Okay? One thing you need to understand though, a parabola does not work if it looks like a C or a backward C, because then it's no longer a function. Okay? In order to have a quadratic, you must have a squared variable. Okay, for example, x squared. This x squared indicates that we have a quadratic, okay? If it's not squared, then we have a linear. That's the difference between quadratic and linear. Linear, that creates a line, has y equals mx plus b or y equals something x, okay? It has a singular x, x to the first degree term, okay? A quadratic has a second degree, so it's x squared. So that's why you know you have a quadratic if you have the x squared value. Okay? So let's talk about each one of these particular terms, because each one of these, the a, b, and c, they all have their own function. They all do something differently for your parabola. So let's talk about that. So the a term. What does this do? Well, this term determines which direction the parabola opens. Example. If you have y equals x squared plus, let's just say 2x squared plus, 2x plus 3, okay? Because this term is positive, opens up. So positive terms open up. So your parabola look like this. The parabola is opening in the upward direction. Okay? Let's say you have the term, another example. Let's say you have y equals negative 2x squared plus 2x plus 3. Okay, negative opens down. So, it may look something like this. Okay. So positive, it opens up. Negative, it opens down. Remember, nothing creates the backward C or the regular C because that would not be a function anymore. Okay. A doesn't just do that. A doesn't just deal with opening up and down. Now that's the primary thing that you're going to focus on this year in 9th grade. But one thing that you do need to know about A is A also determines how wide or narrow the parabola is. Okay. And all of this is generally based on the parent function. And the parent function is y equals x squared. So this determines how wide or how narrow the parabola is, and again, it's based on the parent function, y equals x squared. We determine if it's wider than the parent function or more narrow than the parent function, okay? Now, let me give you an example. There's 3 things we're going to look at. If A is greater than 0, no, greater than 1, excuse me. Let's go to 1 first. If A is greater than 1, okay, it is going to be more narrow. So if A is greater than 1, our parabola will be thinner. Okay? Something like that. And again, it's hard to determine unless you're basing it on the parent function, which we'll talk more about in just a second. So if A is greater than 1, it's more narrow. Okay, example 2. If A is, let me do it this way. If A is greater than 0, but less than 1, okay? So think about what that means. A is greater than 0, okay? That means positive. But less than 1, that means fraction, okay? So if A is a fraction, then you're dealing with a wider graph. So if A is a fraction, you might deal with a graph like this. Or it's a little bit wider. Bigger smile, if you will. Okay, so if A is greater than 1, that's obviously positive. If A is greater than 0 and less than 1, that's still positive. So why didn't I make any mention of the negative number? Well, that's because we already talked about the negative number up here. We said negative opens down, positive opens up, right? We said that in earlier notes. Okay? So, go ahead and get this down. I got one more example to show you as far as determining the wide or narrow. All right. The last example when we're talking about wide or narrow is, what if, this is example 3, what if A is equal to 1? If A is equal to the 1, it is the same as parent function. Okay? The parent function, and I'm actually going to put tick marks on here. The parent function is going to look like this, about right here. So let's say that's the parent function. If your quadratic equation and you have y equals something x and it's just a 1x in the front, or a equals 1, that first number, this number here, if that equals 1, it's going to be the same width as your parent function, which we're going to talk about in just a minute. And that makes it easier for us as we graph things. So whenever we see the 2 in front, we should know that it should be narrow. Okay, let's go back through this again. If it's 2 in front, we should be more narrow. Okay, if it's something like a half in front, so you have y equals 1/2 x squared, you might have something that is more wide, assuming that that blue one is the parent function. Okay? So A does quite a few things. And you're going to be responsible for understanding what A knows this year. And also, you want to hold on to that for Algebra 2, because trust me, as an Algebra 2 teacher, we actually just got done covering this unit again as far as what do the A values do and where do they relate to the quadratic equation and what it does to the parabola. So you're going to need to know this for beyond this year. All right? So that's A. Let me erase this. Let's talk about what B does. Okay? And we're only going to briefly put a few notes up here about B because we don't really talk about the B part in Algebra 1 a whole lot. It's going to come back later when we talk about vertex form in Algebra 2. So don't worry about as much information, but just know this, that the B, again, we're talking about this B right here, okay, shifts the graph horizontally. So shifting the graph means left and right. I'm not going to give you any examples of those because I don't want to get too in depth on that because that's not something that we stress too much in 9th grade. But just understand that when we get to the 11th grade or 10th grade, depending on when you take Algebra 2, for most of you 11th grade, you're going to deal with shifting left and right. And it's really not even the B. It's not called the B by then. It's going to be called your H value, and we'll talk more about that later. Okay? But for now, if you want to know what B stands for, so I don't leave you hanging in the dark, it's basically going to be your horizontal shift. Okay? All right. And then finally, what does C do? And we're going to talk a lot about C in the upcoming days. C, okay, if you notice up here, I'm going to take a little side journey here. If you notice up here, if you remember the linear form, linear was y equals mx plus b, right? So like y equals 4x plus 2. And we used to call this number what? We haven't said this in a while, but we used to call this number the naked term, right? The naked number, because it didn't have a variable. We put the naked number at the back. In the linear form, the naked number was the number that was the y-intercept. It was the constant, okay? So let's look here. Let's fast forward to quadratics now. Okay, notice our term here. We have y equals ax squared plus bx plus c. What term is the naked number now? Okay, that c is that naked number. Okay, that's the term that doesn't have an x value attached to it. So the c is a naked number. If this was the naked number, the b was the naked number here, and it was the y-intercept, what do you think this naked number is? That's right, it's the y-intercept as well. Okay, so the c value acts as the y-intercept. We also say that it shifts the graph vertically. Okay? Meaning up or down. Again, all based on the parent function. Okay, we shift that graph up or down based on the parent function. We're going to talk more about that later. It's called a parameter change, or shifting, or sliding. That's another way that we call it. Translating up and down. There's a lot of terms that we use for that. Translating, shifting, sliding, whatever you want to call it. But this is what C does. Okay? So let's look at some examples. Okay? If we just take our parent function, y equals x squared, when we graph it, and I'm going to color code these so you can kind of see them all related to each other. Our y equals x squared is a parabola that will open up on the origin. Notice, is there a c value here? It's missing, so this is really y equals x squared plus 0. So 0 is our naked number. 0 is our c value. If c equals 0, okay, that means my y-intercept is at 0. Well, my y-axis, that is on the origin. Okay? Now, if I have, it's example 2, y equals x squared plus 2, okay, my graph is going to move up because it's positive. Positive equals shifting up. It's going to move up 2 units. And my parabola will be somewhere right there. C equals 2. So here now I have y equals ax plus c, okay, and that c value is a positive 2, so it's going to take my original equation and it's going to move it up 2 units. Okay. Well, let's look at one more example. Let's say I have y equals x squared minus 2. Well, if positive equals a shift up, negative equals a shift down. Okay? So we're going to shift down 2 units. Again, that's from the origin. So negative 2 on my y-axis, and I'm not shifting it down per se as much as I'm going to negative 2 on my y-axis. So 1, 2, somewhere in here, the graph is still going to go up. Okay? But if you compare it to the parent function, y equals x squared, it did shift down 2 units. If you compare it to this function, y equals x squared plus 2, it shifted down 1, 2, 3, 4 units. So when we talk about sliding, shifting, translating, whatever you want to call it, or whatever that we call it this year, you're going to talk about in relation to another parabola. If I said, okay, what happened between graph example 1 and graph and example 3, you would say it translated down 2 units, or it shifted down 2 units, okay? And that would, of course, be going vertically and horizontally because we're talking about up and down. So that's what our C value does. Okay. Let's talk about a few more things. Let's talk about minimum and maximum. Okay? Now, I'm going to go ahead and give this a regular graph. All right. I've so far shown you only graphs that are on the y-axis. Sometimes they're not going to be on the y-axis. Let's say I have a graph right here. Okay? What can you tell me right now based on looking at that graph? Okay, the first thing you can tell me is A is what? Positive, right? It's a little wide, so you might be able to say A is a fraction. But again, we don't know for sure it's a human graph, but we at least know for a fact because it's opening upward that A is positive. Okay? We know that there was some kind of shift in B because now we've moved left and right. Okay? And we know our y-intercept is 1, right? So our C value is 1. Okay? That's a little more advanced. We'll talk more about that later. But the one thing I want to point out to you is this point right here. What is this point right here? What do we call that point? That point's the vertex, okay? We call that the vertex. The vertex is basically a point at which the graph starts to go the other direction. I want you to visualize this for a second. Think about a football, okay? If somebody throws a football in the air, the ball is going to go up, 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 up. At its highest point, it's going to stop, and it's going to be at a vertex. Okay, and then it's going to start and it's going to go down the other direction. So let me draw that real quick, just kind of an example. If I throw a football, the ball's going to go up, 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 and then at some point it's going to start to go down, right? The vertex is the point at which the direction of the graph changes. So here my graph is going up, 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 hit the vertex, now it's going down. In this case, on this particular one, the graph, if you're going from left to right, is going down, 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 hits the vertex, then it starts going back up. So that vertex is that point in the middle. Okay? Well, the vertex is the point also where we're going to have our axis of symmetry. Okay? This line right here is our axis of symmetry. Okay? It is x equals something. It's the x value of the vertex. So if our vertex right here is over 1, 2, so it's 2 over, up 0, 2, 0. So our vertex is 2, 0. So our axis of symmetry is going to be x, and whatever that value is right here on the vertex. So x equals 2. That's our axis of symmetry. So what does an axis of symmetry do? Well, think about what the word symmetry is saying. Symmetry says it cuts something in half, you're going to have 2 equal parts on both sides. So the axis of symmetry, it splits the parabola in half. So on one side, you should have a point here and an exact point exactly equidistant from the axis of symmetry. So basically, you're cutting that parabola in 2 perfect halves. So that's what the axis of symmetry does. Okay? Now, let's talk about the vertex again. I just wanted to show you the axis of symmetry real quick. Now let's talk about the vertex real quick. Okay, we've talked about the vertex. That's the point at which it changes the directions. Each vertex creates something. Depending on our vertex, okay, I'm right over here. Depending on our vertex, or depending on the location, depending on the location of the vertex, okay, there is either a maximum or a minimum. Okay? Every single quadratic or parabola has a max or a min value. Okay? The maximum or minimum value is based on the y value. In this case, we have a minimum equal to 0. Because the y value is 0 and the minimum is how low it can go. Think about you holding a sack and then dropping a ball into it. If you're holding a sack, okay, and you drop a ball in there, it's got a point at which it can no longer go down anymore. It's not going to hit the ground, unless of course you have a hole in the bag, but it's not going to hit the ground. So it's got a minimum distance until it hits that bottom of that bag, and it cannot go any lower than that. That's what a minimum is. Okay, if you think about this as a bag right here, and if I drop the ball in here, that ball's going to keep going down, 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 and then it cannot go any further. So that's a minimum point because I can only go so low. Okay, and we're going to talk about domain and ranges of that later, but that's a minimum point. So if the parabola opens up, so parabola opens up, then there is a minimum. Of course, the direct opposite of that would be a parabola opening down. So let's say you have a graph here and a vertex is over here. Here's my parabola now. Okay, well think about that as like a canopy over your head or a ceiling. Okay, if I'm in the room right now and I throw a ball up, it only goes to a certain height. At some point, it's going to hit the ceiling and it can't go any higher than that. That's called a maximum height. We can't go any higher. It's a maximum height value. Okay? And in this case, my vertex is 1, 2, 3, 0. 3 over, 0 up. So my maximum value is equal to 0 also. Here I had a minimum value equal to 0 because my y value is 0, but I had a parabola opening up, so it has a minimum. Here I have a maximum value because my parabola is opening down. It just so happens that my vertex is 0. Remember, that maximum value is based on the y value of the vertex. Okay, so when the parabola opens down, then there is a maximum. Okay? So when the parabola opens down, then there is a maximum. Parabola opens up, then there is a minimum. Okay? All right, any questions on that? Okay? If you have any questions, write them down and bring them to me in tutoring or ask me tomorrow when we do Monday when we do our activity. Okay? A lot of information here. You're probably going to have to write this down and go back over it again. Save this video so you can go back over it again. This is a lot of information. I know this is a longer video, but this is a lot of information on quadratics. Okay? The last thing we're going to look at, so I can kind of minimize the length of this video, I know it's still very long, but just kind of minimize a little bit more, is we're going to look at the parent quadratic. So the parent quadratic function we've already talked about this a little bit. It's been a long time since we've talked about it. But if our linear quadratic is y equals x, okay? So our linear parent linear is y equals x, okay? And that makes sense, right? Because we said in order to have a straight line, we had to have a singular x value. That means it's not squared. If our parent linear function is y equals x, what do you think our parent quadratic is? Okay? Y equals, not x, because that would be linear, y equals x squared. We have to have that square term in order to have a quadratic. So that's our parent quadratic function. Okay? Let's go ahead and graph that real quick. Now, quadratics are harder to graph than linear. Okay, there's no special way to graph quadratics. A lot of times we're going to have to make a t-table for it. So what we're going to do is we're just going to make a quick t-table for this graph. Okay? We're going to do negative 2, we're going to do negative 1, we're going to do 0, 1, and 2. What we're going to do is we're going to plug it in. All right, so if x equals negative 2, I'd have y equals negative 2 squared. So y equals 4. Negative 2 times negative 2 is a positive 4. So there's my 4 value. Okay? If y equals negative 1, x equals negative 1, negative 1 squared, negative 1 times 1 is positive 1. If x equals 0, y equals 0 squared, y equals 0. Okay? If y equals 2 squared, x equals, 1, following our table. If x equals 1, y equals 1 squared, y equals 1. And if y equals 2 squared, or x equals 2, y equals 4. So now we've done a table, so now we can plot these points on our graph, okay? And notice the pattern. Positive, positive, 1, 1. These numbers start to repeat themselves. That's how you get the U shape. They're going to have to repeat themselves. If they're all different, you're not going to have a parabola. So let's graph this. Go over negative 2, up 4. Right here. Go over negative 1, up 1. Go over 0, up 0. Now that's our y-intercept. We should have known that was going to happen because we have a 0 y-intercept. Y equals x squared plus 0. So that's our y-intercept. Okay, so that's true. So we're going to go over 1, up 1. Go over 2, up 4. So now we've created our parabola. Make sure we draw the line, or the parabola. So there's our parent function, okay? Notice our axis of symmetry. Well, let's look at our vertex. What's our vertex? It's that point right here. The vertex is 0, 0, right? That's where the point is. What's our axis of symmetry? AOS. Remember, axis of symmetry is x equals something, and it's x equals the x value of the vertex. So x equals 0. Well, where's x 0? Right here. So then I draw a vertical line on the y-axis. So our y-axis actually is the axis of symmetry on this one, but it's written as x equals 0. Okay? Do we have a maximum or a minimum? Okay, we have a minimum, right? Because it's positive, it opens up, it only can go so low. Our minimum value is the y value of the vertex, so our minimum is 0. Okay? So this is our parent quadratic function. The reason this is important is because we're going to talk about this, and everything, a lot of what we do is we relate it to the parent quadratic. If I plus 2, I'm shifting it up 2. If I subtract 2, y equals x squared minus 2, I'm going to shift it down 2. But it's all based on that parent quadratic function. And the parent quadratic function is always at these points. Always. If it is the same shape, okay, if I have a graph that's the same shape as the parent quadratic function, okay, what's going to happen is, remember, that means a equals 1. Okay, what's going to happen is my graph is maybe shifted up or down, but I'm still going to go over 1, up 1, over 2, up 4, and I'm still going to get the same shape. That's why it's important. Again, a lot of that deals with Algebra 2, but that's stuff that you're going to need to know as you move forward. Okay? All right. One of the things we didn't talk about today was domain and range. We talked about a lot of information. I know it's a lot. Please make sure you've written all this down. If you didn't write it down, go back, watch the video again, write it down. We are in go time. It's time for us to get prepared, get learning. This is great information, great knowledge. When you come in on Monday morning, we're going to get started. We're going to get after it. If you don't watch the video, well, you're not seeing this message anyways. You're going to be lost. But make sure you watch the whole video. I hope that you did. Again, if you didn't catch this part anyways. I'll see you guys on Monday. Good job. Hope you had a good weekend.